In this lesson we will go over something new called the law of sines, and we use it to solve triangles that are not right triangles, and those are called oblique triangles. We've been using sine to solve right triangles, and we can do it like this, where sine 30 is opposite over hypotenuse, and then we write an equation and we get the missing side. And with the law of sines, we have a triangle that's oblique. It's not a right triangle, and we can still solve it. We just have to use sine differently, and we'll make we'll put x over sine of its opposite angle. So we focus on these opposites. Opposite side, opposite angle. Here's the 120, and its opposite side is 5. So these pair up, and the 30 and the x pair up. So we can write x over sine 30, 5 over sine 120. And then from there we're just solving for x. So we can multiply both sides by sine 30. We can evaluate the trig functions, and we end up with this for the missing side. So that's what we'll be using today. And then we also want to be aware of some triangles that have more than one solution. So if we have this triangle, we could label that as a side-side angle. This can have 0, 1, or 2 solutions. So we have to be careful with that one. And we could call this one and side angle angle, or angle angle side. We could call this an angle side angle. And if there are two known angles like here, then there can only be one solution. But if there's only one known angle, then the other two angles can vary, and that can create more than one solution or no solutions. We will use law of sines for these if we did have one angle and two sides like this. This can only have one solution. We can't use law of sines for this. We would call that a side angle side. So side angle side has one solution. We can use law of cosines, which we're not doing today. But for side-side angle, we would use law of sines, and we could have 0, 1, or 2 solutions. So we'll get to that at the end of the lesson. So sometimes instead of memorizing different cases and the procedure used for different cases based on what's given, why don't we just always look for what's easy to find first? What can we find easily? Well, this angle is the third angle, so we know that if we add all the angles up, it's 180. So let's find angle H first, because it's easy to find. And we know that all the angles add up to 180, and so we'll just subtract the 53 and the 112, and we know that the angle H is 15 degrees. Then we want to make sure, if we're going to do law of sines, we have to use opposites. We have to know a pair of opposite side and angle, and now we do 15 here and 18. So we know the opposites, and that will let us find the missing side. Let's find side F first. I want to find side F, so it's nice to put the variable in the numerator. And then we'll have side H, which is 18 over sine 15. And we could write this proportion with the trig functions on top in the numerator. It doesn't matter. Let's multiply by sine 53. And we'll just put that into the calculator, and we get and then we have side G. So we have G is opposite of 112, so we'll make sure we make a ratio with G over sine 112. And then let's keep using the known value 18 over sine 15. Multiply both sides by sine 112. And we get approximately 64.482. Alright, so make sure you know that's an S, not a 5. So we have S there. Pause the video and try that one. So it'd be easy to find angle S. Let's find angle S first, and that will be 180 minus 62 minus 56, and we get 62. And then we want to look for a pair of known values, of known opposites. So we have 62 and 7. Those are opposites, so we need to make sure we use that for law of sines. And then we can find a missing side. Let's find side R. So it'll be R over sine 56. And then we'll use 7 over sine 62. Multiplied by sine 56. And R is approximately 6.573. So we know side R. Let's find side S, and its opposite of angle S, which is 62. So we're going to go S over sine 62. And let's keep using the same ratio we used before, 7 over sine 62. You can see that S is going to be 7 because the denominators are equal, but we can go ahead and show the work. Multiply both sides by sine 62, and we get 7. And let's see how there can be more than one or less than one solution, and that's with side-side angle. And here a solution is a triangle that can be drawn with the given characteristics. So if we have angle A is 35, side A is 3, side B is 10. Is this possible? And could we draw two different triangles that have these characteristics? So let's draw. Suppose that we can draw a triangle and it looks like this. Make sure that side A is opposite of angle A. So here's angle A, side A, angle B, side B. And here's how we tell if there is one solution, or if there are no solutions. Let's find the height. And so the height here, if we did right triangle trigonometry, we have sine of 35 is h over 10, and then we have 10 sine 35. So the height is 5.736. And now we look up here. If the height is 5 or more than 5, then this hypotenuse of this right triangle has to be larger than 5. If this is only 3, then it will not form a triangle. And if we had to use these dimensions, then if this is a 35 and that's 10, then if you only had a length of 3, it wouldn't reach the base of the triangle. So this has no solutions. And the way we can tell that is the opposite side is less than the height. Opposite side less than the height. All right, let's look at what if we have A is 35, side A is 7, and B is still 10. And it's the height is still a little over 5, so that means 7 is greater than the height, and we could draw a triangle like this. But let's see if this is the only way we can draw this triangle. This 7, the side length with the side with length 7 could have been drawn out here, or what if it was drawn in here? It would still fit in here because this is 10 and this is 7. This is still 35. So we could draw a triangle with the 7 out here or a triangle in here. And that gives us two solutions. Two different triangles that can be drawn with these characteristics. And that occurs when the opposite is less than the adjacent. The opposite of 35, the opposite is less than the adjacent, has the possibility of having two solutions as long as the opposite is greater than the height. And we'll look at this in an example. What if we have A is 35, side A is 12, side B is still 10, and we draw that triangle. So what if we try to swing this side? Do we have to draw the triangle with the side out here, or could it be drawn in here? And because it's longer than the adjacent, if it swings through, it won't meet the base and it won't form a new triangle. With this shorter side, and as it rotates, it'll hit right here. As this rotates, it goes beyond the base. So this only has one solution. And that's when the opposite is greater than the adjacent. We can have one solution. So now we have to draw and check some of the possibilities. And the 18 is less than 38. So there might be two solutions because the 18 could swing in like this, but we do have to see what the height is. So we have sine 30 is h over 38. Sine 30 is 1/2. We'll go 1/2 of 38 is 19. 18 is less than 19, so there's no solution. If we try to draw this triangle and we have a height of 19, when we try to draw the 18, it will stop and it won't reach the base. This is only 18, but it has to go the length of 19, so there's no solution. All right, pause the video and try that one. All right, B is 61. Opposite of angle B is side B. And we have the opposite is less than the adjacent. There could be two solutions, but we have to check the height. So to find the height, we have sine 61 is h over 12. 12 sine 61 is h, and 10.5 is the height. 8 is less than 10, so that means this cannot make a triangle. There's no solution. If we tried to draw the triangle with a 12 here, the 8 is not going to meet the base, and there's no solution. So here we have, let's draw it and see what's happening. The height is sine 38 equals h over 10, so that's 10 sine 38. And the height is 6.157. The opposite is greater than the height, so that means we do have a triangle, and the opposite is less than the adjacent. That means this could rotate in to make a different triangle. If that is an 8 and that is an 8, then the triangle that we have right here, this triangle, is isosceles, and that means we know that this angle is equal to that angle. So that's a characteristic of the two-solution case. So since there are two solutions, let's draw each triangle. We have the triangle that looks like this, and we have the triangle that looks like this. Now, this C is different. This angle C is a different measure than this angle C. So let's call that C1 and C2. This B, angle B, is different from this angle B, and that's B1 and B2. And this side C is different from this side C, so that'll be C1 and C2. That's lowercase c. Uppercase C is for the angle. So we're looking at this. We can't find an angle. We have to find angle B first. We can't find an angle without using trig. So here let's find angle B. Sine B1 over 10. And then we'll have sine 38 over 8. Multiplied by 10. And do inverse sine of both sides. So we get B1 is approximately 50.316. If we know that this is 50, then we know that that is 50 and that is 50 over there. If this angle is 50, we have to subtract it from 180 to get that angle out there. So in this picture, we know that this angle is 50.316. But we don't want this angle. We want the angle, its supplement in here. And that's why to find B2, we're going to do 180 minus 50.316. All right, and then back on this triangle, now we have two angles, so we can find a third angle just by subtracting from 180. So angle C1 is 180 minus 50 minus 38, and we get 91.684. And then, well, we did it for the first triangle. We can do the same thing for this triangle because we know there's a 38 and a 129, so we can find C2. C2 is 180 minus 129.684 minus 38, 12.316. And then we can find the missing side C1 because we know that angle now. So we're going to go C1 over sine of 91 equals 8 over sine of 38. And then we'll multiply both sides by this. And with the calculator we get 12.989. And we'll do the same thing with the other triangle. If we want to find C1, side C1, we look up here, no, side C2. Side C2 over sine of angle C2. Side C2 over sine of angle C2. And then we can do 8 over sine 38. Pause the video and try that one. So we see that 18 is greater than 12. The opposite is greater than the adjacent. So that means there cannot be two solutions. If we check the height, The height is 12 sine 27. And the height is 5.447. 18 is greater than the height, so this does form a triangle, and there's only one solution. If we tried to swing 18 inside, 18 is bigger than 12, so we couldn't make a different triangle. So we'll just start solving this. We need to find angle B. So let's start with to find angle B, we'll go sine B over 12. Sine 27 over 18. Inverse sine of both sides. And B is approximately 17.617 degrees. And once you know two angles, you can find the third angle. Angle C is going to be 180 minus the other two angles. We get angle C, and then we'll find, so we know angle C, we know angle B, let's find side C. So it'll be C over sine of this. Side C, we're going to have C over sine of 135. And then we'll do 18 over sine 27. So that's the missing the last side. And that's the end of this lesson.